Assalamualaikum and a very good day. My name is Rajina Bidishami Sivraj from UITM Ara. The topic presented today is exploring the physicochemical properties of citric acid monohydrate and glycerol, a deep eutectic solvent. Deep eutectic solvents, also known as DES, is an emerging class of green solvents composed of a hydrogen bond donor, also known as HBD, and a hydrogen bond acceptor, also known as HBA. In the study, the DES was formed from the combination of citric acid monohydrate and glycerol. This combination creates a eutectic mixture with a lower melting point than its individual components. DES possesses unique physicochemical properties such as low volatility and biodegradability. These properties make DES particularly attractive in various applications, including the extraction process, where it provides an eco-friendly and efficient alternative to traditional solvents. Recently, there has been growing scientific interest in extracting bioactive compounds from plant sources. Conventional extraction methods often rely on organic solvents, which pose several challenges, including volatility, hazardous nature, poor biodegradability, and flammability. Therefore, to address these limitations or concerns, the need for a biocompatible and effective alternative solvent for a better extraction process is crucial. The significance of this study is that DES is widely recognized for its environmental sustainability and flexible properties, and the characterization of the DES emphasizes their suitability as an effective solvent in applications like plant-based extractions. The main objective of the study is to investigate the physicochemical properties of the citric acid monohydrate and glycerol as a DES. In our methodology, we first prepared the deep eutectic solvent by combining the citric acid monohydrate and glycerol at a molar ratio of 1:2. These components were constantly heated and stirred together at 80 degrees until they formed into a clear and homogeneous mixture. Next, the DES was analyzed using the Fourier transform infrared spectroscopy, also known as the FTIR analysis, which was to observe the functional groups and possible shifts within the solvent. Following this, the DES was also analyzed with the polarized optical microscope analysis, also known as the POM analysis, to observe its properties in detail. Next is the pH value test. The pH value of the DES was tested using a pH meter at various temperatures. The selected temperatures were 4, 25, 37, 45, 60, and 80 degrees Celsius respectively. This determines how the temperature impacts the pH level of the DES. After that, the viscosity of the DES was measured with a viscometer, which uses the same temperatures as the pH test as mentioned. This test helps understand the fluidity of the DES under different thermal conditions. Following this is the density test. For this test, a 10 milliliter volumetric flask was used. The density was calculated using the formula density equals mass over volume, where the mass is the difference between the weight of the flask with or without the DES, and the volume is 10 milliliters. As for the solubility test, we mixed 2 milliliters of DES with 2 milliliters of selected organic solvents with different polarity ranges. Then the mixture was vortexed, and the separation line between the solvents helped determine its solubility results. Finally, the surface tension of the DES was measured using the Wilhelmy plate method, and the results were calculated with a built-in software. As for the resultant findings, we will first explore the spectroscopic and microscopic analysis, which is divided into the FTIR and POM analysis. Starting with the FTIR analysis, this table focuses on the various functional groups of the HBA, HBD, and DES mixture. First of all, the wave number for the OH group of the citric acid and glycerol components individually had shifted to 3,322 for the DES formation. the wave numbers for citric acid for the C double bond O group and the CH2 group had decreased to 1,715 and 1,397 respectively during the formation of the DES. Additionally, the C single bond O group had shifted from 1,108 in glycerol to 1,190 in the DES mixture. These shifts relatively reflect the hydrogen bonding and other interactions between the groups, or the HPA and HPDs, indicating a successful synthesis of a homogeneous DES. The next analysis is the POM analysis, which observes the visual characteristics of the chosen DES. The clear liquid and the absence of crystallization within the DES further validates it as a successful eutectic mixture. This homogeneity also contributes to a chemically stable solvent suitable for natural product analysis. Following this is the pH value. Results deem that the chosen DES is acidic in nature. This is because citric acid monohydrate is indeed an organic acid. Moreover, the increase in temperature reduces the pH value further because of the higher acid dissociation as the hydrogen bonds between the citric acid monohydrate and glycerol weaken. In terms for extraction, the acidity determines the polarizability in extracting targeted bioactive compounds. Next is viscosity. The aim for this test is to identify the molecular level interactions within the liquid phase through the thickness of the chosen DES. Results showed a progressive decrease in the chosen DES's viscosity with rising temperature. This is because it promotes intermolecular spacing within the DES, hence decreasing its viscosity. In terms of extraction, the high temperature allows better interactions with other solids such as bioactive compounds. The next characterization is the density test. The chosen DES had exhibited a rather dense liquid of 1.362. This is because the higher concentration of hydrogen bonds typically reduces the free volume space, which results in a more dense and compact structure overall. After that, there is the solubility test. This test is to identify the ability of DES to solubilize in various solvents with different polarities. Overall, the chosen DES was categorized to be hydrophilic, as it was miscible or soluble in highly polar solvents such as water. This is because both glycerol and citric acid monohydrate are polar in nature. The final characterization is the surface tension test. So this test is to determine the external energy required to penetrate the surface area of a liquid in a fixed volume. The chosen DES had displayed a high surface tension of 58.28. Apart from glycerol being highly viscous in nature, the surface tension mainly arises from generations of electrostatic forces, van der Waals interactions, and hydrogen bonding. Overall, it can be observed that the high physicochemical properties can be easily adapted through elevated temperatures and dilutions for extraction purposes. In conclusion, this study has successfully demonstrated that the chosen DES can function as an eutectic solvent due to the expected eutectic properties observed. Overall, the findings suggest that this solvent exhibits a stable structure suitable for a wide range of applications, like an eco-friendly alternative to conventional organic solvents. These are my references. Thank you very much for lending me your ears and giving me your time.